Hello friends, I welcome all of you. In this video, we'll talk about transport layer in bit of detail. We have already discussed about this topic, but I want to go in detail as this topic is very important and a lot of questions may be asked in the exam. And moreover, this is very useful once you get into troubleshooting scenarios in your company or in enterprise. So let's get started. Just take a look at the screen. So we know there are a total of 7 layers in the OSI reference model, and in that transport layer sits at the number 4 position. We know that encapsulation happens at the sender end and decapsulation happens at the receiver. So when sender tries to communicate, then we notice that in the first 3 layers the PDU, that is protocol data unit, remains data. There is no encapsulation, and at this layer the encapsulation happens. So what happens in that, L4 header is added. It will be either TCP header or UDP header, and the data will be segmented. Means it will be divided into segments or in user datagram, right? And then it goes to network layer, and at the receiver end, once the PDU is received, it will decapsulate. I mean, this transport layer will start the process of decapsulation, and in that process it will strip off the L4 header and read the segments and rearrange. This is known as segmentation and reassembly. Alright, so main job of transport is to move the data stream from one place to another, but here we are trying to know all of the points as well. I'll come back to the main point, that is end-to-end delivery. So this portion is completed. Now let's talk about connection management. How does the connection establish? See, there are 2 protocols, TCP or UDP. So based on that, connection management will happen. UDP is very fast, its header is very small, it doesn't contain many options or much information. So when with the UDP based application, once a connection is established and if there is any error, it will break. It will not try to recover. Okay, so that is a challenge with UDP, but it's very fast, it's light, and there is no flow control in that. There is no windowing, no error detection like that. In the TCP, how does the connection management will happen? Sender, and this is receiver. Sender will send SYN message, okay, and if receiver is ready, it will send acknowledgement to SYN. It will be SYN acknowledgement, and then sender will reply saying okay, let's start. So this is known as 3-way handshake. Okay, so it happens in the TCP when establishing the connection, and if it has to break the connection, let's say that sender wants to break it. So whichever party wants to break or finish the connection, it will send finish, FIN message, and then there will be acknowledgement of the FIN message. So either party can finish, right? Sender or receiver. In this case, let's say sender initiated. After that, sender will send the finish message, wherein it will be mentioned like I'm done with data transfer, and in the last it will tear down the connection. So it will be 4-way message exchange when finishing or tear downing the connection, but this doesn't happen in UDP. It is down directly, no such messages will be sent. So this portion is done. Now let's talk about this end-to-end delivery. What does it mean? See, our main job is to transfer the data from sender to receiver, right? But what does this end-to-end mean? End-to-end mean port to port, which also means application to application. See, what we do in the internet, we access the other server using an application, right? So if I'm accessing, let's say, my router using SSH, it means that SSH client is also installed in my workstation, and also it's there on the destination. So an application should be there in both end. Main application server will be there on the server, but the client of that application will be there in your. Just like I access browser and open many websites, cisco.com, abc.com, whatever. So I use Chrome application, which means that you have web services enabled on your client. Okay, so we access many applications. I told you SSH, telnet. Like if I'm communicating with my router, I'll use either telnet or SSH or both. Okay, and there can be multiple sessions. Similarly, for the website, there can be multiple tabs, right? So for each connection, transport layer needs port number. Okay, so for, let's say, YouTube, it's a browser based application, right? So it will be TCP 443. Okay, so in the header there will be two options, two fields. One will be source port and other will be destination port. Destination port is the port of the application which is hosting YouTube, and the source port will be a random port number which is allocated by your workstation to the process, the same process or same application. Let's say in the Chrome browser you open tab 1, then tab 2 and tab 3. Tab 1 is for this YouTube. So for tab 1, it will allocate a random port number less than 65,535 but greater than 1024. So random port number can be like 10,001. Alright, so it is actually done to identify the connection. Okay, let me clean it and explain you again. Source will have multiple connections. Similarly, the receiver will also have thousands of millions, right, or multiple applications. Source will be identified with socket address, which will have three fields. First will be the type of protocol that we are using, TCP or UDP. Okay, let's say TCP. Second will be the IP address, and third will be the port number. So at the client it will be random port number, let's say 10,001, and for the destination, three fields will be like TCP, the IP address of the destination server, and the well-known port number. So what are the well-known port numbers? The port number which are reserved for the application. So these are first 1024 port numbers. All right, so 443, right? So connection will have this detail. Only then it can be identified, like for which process the traffic should be returned, right? You asked for something, the server is ready for that, but it should know to which client I should forward. That it can find out from its connection table, and based on the IP address it will send you. But once the data is received by your workstation, then your workstation should know for which process this data is for, or this material it is for, right? So that will be based on this port number. So it's a port to port delivery, that is end to end delivery. Understood? This is the main reason for it. And transport layer does flow control and congestion avoidance. Flow control will have a concept. If client is sending the data at very high speed which receiver is not able to handle, So it will send its requirement stating this is my window size, don't send me data beyond this window. Okay, so this is how the flow will be controlled. And congestion management, if a receiver is too busy handling requests of other clients, then there may be congestion. So it has a feature of congestion avoidance. Okay, both are part of TCP only, but TCP is a part of transport layer, that is why. And this error detection is like if there is any problem in the media, there could be an issue at the ISP level or at the at any level, right? So it will detect it. Or if the frames have been corrupted, or there is some congestion which caused frames to go out of sequence, then this mechanism will help. All right, there is a checksum value as well. Checksum value, remember that, which will ensure that frames are not corrupted. If it is corrupted, then it will ask for resending of the same, not frames, sorry, segments. So if there is an issue in the segments, then this error detection using checksum will be very helpful. All right, and what is this multiplexing and demultiplexing? Very simple. Like this is your client. It made a request to google.com, let's say. It replied. Now client has to know to which application I should forward this response. There may be multiple instances of browser opened up, or SSH or telnet, right? So based on the source port number, it knows, right? But this actually concept is known as multiplexing. Okay, because ultimately we have a single connection here. We don't have many connections, only one ISP. But internally we have many. Okay, so it's a one to many. One connection to many. It is multiplexing, and other way around is demultiplexing. Like when you initiate the request, there are multiple processes running, and all the requests will be sent to single ISP, single LAN. That is demultiplexing. That is this one. Alright, so multiplexing and demultiplexing are part of transport layer. So just as a recap, the main job of transport layer is to transport the PDUs from one location to another. It will be end-to-end delivery, that is port-to-port delivery. And main work is it does segmentation. It is layer 4. It does reassembly at the receiving end. It uses TCP or UDP, and based on that, the connections will be handled. For TCP, the connection initiation will be handled with 3-way handshake, and finish or tear down will happen in 4-way. And in UDP, it is not the concept. Flow control is there just to ensure that receiver doesn't get too many segments. Okay, so it sends a window, means it sends its requirement to the sender stating that this is my capacity, and don't forward me anything beyond this. And based on the checksum, it is able to recover from the errors. Okay, and congestion management, just like your server is busy, so it will send a message stating that I'm not ready for it, please don't send me anything. And error correction will be like if some segment is lost or user datagram is lost, it will request for resending of the same. It will be done. Multiplexing, I told you, internally there are many processes of the applications are running. So actually we have a single LAN card, so all processes are linked with the LAN card, right? So when client makes a request from the process, it actually goes through same IP. So this process is multiplexing, and demultiplexing will be like when the response comes back, right? So very simple thing, nothing to worry at all. This is just a theoretical work. That's what I wanted to tell you. And also I talked about the socket address, which is a combination of three things. That is protocol plus IP plus the port number. So well-known port numbers are from 1 till 1024, that is first 1024 ports, and these random port numbers are ports above 1024 and less than 65,535. So these are the total number of ports. Okay, each protocol will have, TCP will have these many and UDP will have these many. Alright, so some of the well-known port number like 20, 21 for FTP, 22 for SSH, 23 for Telnet, 25 for SMTP, right? And 69 for this one TFTP, UDP, 53 for DNS for both UDP and TCP. Okay, and I think DHCP uses 67 and 68. You must remember these port numbers. These are all well-known port numbers. So friends, thank you so much for your time. Have a nice day.